Good evening, guys. I'm going to give you some notes about slant asymptotes. I think I said I was going to give you notes about holes for tomorrow, but that's actually on Monday. I forgot we were going to do slant asymptotes first. So what I'm going to do is I'm going to show you how to find a slant asymptote, and then tomorrow in class I'll actually give you an example where we will go through the whole list of how to do everything. But in order to find a slant asymptote, you're going to have to do synthetic division. So let me review with you how to do synthetic division. So if I had x squared minus 9 divided by x plus 2 and I wanted to divide this out, actually divide it and get an answer, I could use synthetic division to do this. And here's how we do that process. The first thing we do is we take the denominator, x plus 2, and we set that equal to 0 and solve that. And we get x equals negative 2. Now, it turns out that that is still a vertical asymptote for this problem, but when you're doing synthetic division, we're going to use it as part of our synthetic division. Now, what I'm going to do is I'm going to take that negative 2, and I'm going to put it in a box here. Now, some of you may remember this process, so hopefully this will be a review for you. So put a negative 2 in the box. Now, on the same row as that box, what I'm going to do is I'm going to write down the coefficients in the numerator. So when we start off with this x squared, the coefficient is a 1. So I'm going to put a 1 there. I have no x in the numerator, so I'm going to put its coefficient as 0 because I have to account for every power of x. So the 1 is for the x squared, the 0 is for x, and then I have a negative 9. So I'll put those on the same row as the box. And then I'm going to leave another row so that I can write numbers in there. Okay. Now here's how synthetic division works. We take the first number here and we just drop it straight down. And that's a 1. Alright? And then we take this 1 and we multiply it by the number in the box. So 1 times negative 2 is negative 2, and then we write that in the next spot, or the next column in my little chart here. And then we add these up. So 0 plus negative 2 is negative 2, and now we do the same process again. We take negative 2 and multiply it by the number in the box. So negative 2 times negative 2 is positive 4. And we write that in the next column, and then we add those and we get negative 5. Now, when we do these problems, the last number we get, that is our remainder when you're doing synthetic division. Now, for our purposes, the remainder is irrelevant. We're just going to ignore it. What's left will actually turn out to be my answer, which is my slant asymptote. So when we're looking at this problem as far as synthetic division goes, we're going to ignore the remainder. This number right here, the number right next to the remainder, is the constant, which means it does not have an x with it. And then the next number is the coefficient of x to the first power. So my answer here for this problem, if I was just doing synthetic division, my answer would be x minus 2. So when I take x squared minus 9 and I divide it by x plus 2, I get x minus 2 with a remainder of negative 5, but we're ignoring the remainder. Okay? It turns out that this x minus 2, if I make that y equals, that is a slant asymptote for this problem. Alright? Now, how would I even know that this problem had a slant asymptote? Well, let's kind of take a look at our rules for this problem a little bit. I just want to look at the asymptotes. So if I was going to find a vertical asymptote for this problem, the rule stays the same. I take the denominator, I set it equal to 0, and I solve. That would be my vertical asymptote, negative 2. Okay? For the horizontal asymptote, what we do is we take the degree of the numerator, which is 2, that's the highest power of x, and then the degree of the denominator is 1, and we compare those. So when I take 2, I see that it is greater than 1, and from the rules that I gave you in the video a couple nights ago, if the degree of the top is bigger than the degree of the bottom, then we have no horizontal asymptote. Now, if you have no horizontal asymptote, there is a chance that you have a slant asymptote. If you have a horizontal, you cannot have a slant. Okay? So, you may want to write this down. You cannot have a horizontal asymptote and a slant asymptote. And this is huge. Okay, you cannot have both of those. All right, so in this case, we do not have a horizontal, so there is a chance that we have a slant asymptote. And here's how you know. Here's your rule for slant asymptotes. So slant asymptote. If the degree of the numerator is 1 greater than the degree of the denominator. That's how you know you have a slant. All right, and that's the number 1 there. Okay, if the degree of the numerator is 1 greater than the degree of the denominator. So in this case, when we look at this, 2 is greater than 1, so that's none for horizontal, but 2 is 1 more than 1, so that means I do have a slant. And in this problem, this would be my slant. Now tomorrow I'm going to use this same example, x squared minus 9 over x plus 2, and we're going to go through everything, the x and y intercepts, horizontal, vertical, slant asymptotes. We'll talk max and min, domain range, all that, and we'll put that all into one example and do that. But this is how you will find a slant asymptote for our problems, is you will do the synthetic division on it. So hopefully you've got that in your notes, and then we'll look at, actually we'll probably do another example tomorrow, not the same one, but I'll give you another example where we go through everything, and that'll give you another example of how to find the slant. But you do have to do synthetic division to find the slant. See you guys in class tomorrow.